Okay, so topic for the day is VLSM. VLSM stands for Variable Length Subnet Masking. Guys, this is a user demand video. One of my subscriber has requested me to make one video on VLSM. So today in this video, we will discuss what is the exact process to do VLSM, to perform Variable Length Subnet Masking, right? First of all, let me remind you subnetting. Suppose I have one network 192.168.10.0/24 and I want to divide this network into two parts, right? We need to borrow one bit from my neighbor, because remember the formula to calculate number of network. Formula to calculate number of network equals to 2 to the power n, where n is number of network bits borrow by host bit, right? So by default here you can see this is IP address of class C. In first octet value is 192, right? So by default CIDR value for class C is /25, means in last octet all bits is 0. 3, 4, 5, 6, 7, 8, all bits is 0. We need to turn on one bit. You have to set first bit to 1 from 0, right? So n will be 1. So number of network will be what? 2 to the power n means 2. Now how many network are there? If I will set /25 over here, that means there are two network now. First network is 192.168.10.0 and second network is 192.168.10.128. Am I right? Because you need to find block size. So block formula to calculate block size is 256 minus subnet mask of that octet where last one is present. So last one is present in fourth octet. So what will be the subnet mask of this octet? 128, because there are only one first bit is on, right? So 128. So you will get to 128 over here, right? So your second network is starting from here and your first network is starting from here, both /25/25. What will be the last IP address of this network? 192.168.10.127, and last IP address of this network 192.168.10.255. Am I right? Now how many valid hosts are there in this network? How many valid hosts are there in this network? So formula to calculate valid host is 2 to the power h minus 2, where h is number of host bit, Am I right? Minus 2. So what is the total length of IPv4 address is 32 bits, right? So out of these 32 bits, 25 bits are network bits, right? So you need to subtract network bits from 32. So you will get 7 over here. That means there are 7 host bit. Now h equals what? 7. Means if you will put 2 to the power 7 minus 2, you will get what? 126. So you can configure 126 computer in this network, right? And in this network also you can configure 126, right? So you can see, guys, length of my network is same. Length of both network is same. So this is FLSM, fixed length subnet masking, right? Means length of my all network is same, right? Equal. Now if my requirement is different, if I want that in my first network there can be 120 user and in second network there can be 20 user only, right? In that scenario, when the length of your network is different, in that scenario we need VLSM, variable length subnet masking. If length of all network is same, we don't need to perform VLSM. FLSM is fine for that scenario, right? But if the length of my network is different, length is varying, right? In that scenario we need VLSM. Let me take one example so that it will be make you more clear. Suppose in an organization, in a company, there are 4 departments. How many departments are there? There are 4 departments. Suppose my first department is sales and purchase department, sales and purchase department. Second department is, suppose second department is my development department, is my development department, main department. Third department is my, suppose third department is my accountant department, and fourth department is, suppose, management department. Okay, now we have 4 department in an organization, and in department 1, in sales and purchase, we need to connect 120 computers. How many computers? 120 computers. In department 2, in development department, we need to connect, suppose, 50 computers, right? In department 3, in accountant department, suppose we need to connect 26 computers, right? And in management department, suppose we need to connect 5 computers, only 5 computers, right? Here you can see the length of my network is not same, length is varying, right? In department 1 we need 120 IP address, in department 2 we need 50 IP address, in department 3 we need 26 IP address, and in department 4 we need only 5 IP address. So here we can't perform VLSM, here we need to do VLSM, variable length subnet masking, because length of my network is variable, right? Now length of my network is not same. Okay, now the first step to do VLSM is arrange all segment in decreasing order, right? First of all, we need to arrange all segment in decreasing order. So guys, in department 1 we need 120 users, right? In department 2 we need 50 user, in department 3 we need 26 user, and in department 4 we need 5 user. So you can see these are my segment in decreasing order, right? Now if administrator will give you this network 192.168.10.0/24, and we have to do VLSM with this network. This is my main network, right? So first of all, I will perform VLSM for department 1, right? Who for which segment? For the segment where we need highest IP address. So you can see in department 1 we need highest IP address. Then we will perform VLSM for second highest IP address for this one. That's why I said that you need to arrange your segment in decreasing order, right? After that I will do VLSM for this network, after that for this subnet. Okay, fine. Now okay, so first of all, for department 1 we need how many hosts? 120 hosts, and formula to calculate valid host is 2 to the power h minus 2, right? 2 to the power. So valid host must be equal to or greater than 120. This is my requirement, right? My valid host should be greater than or equal to 120, and formula to calculate valid host is 2 to the power h minus 2. It will be equal to and greater than 120. What will be what value you will put here? What value you will set to h, right? If you will set 1, this condition will not fulfilled, right? If you will put h equals 2, this condition will also not fulfilled. If you will put h equals 6, so 2 to the power 6 will be 64 minus 2, that means 62. Now my requirement is not fulfilled, so you need to put h equals 7 over here, right? You can see 2 to the power 7 minus 2 greater than and equal to 120. 2 to the power 7 is 128 minus 2 means 126 is greater than and equal to 120. Now my requirement is fulfilled, right? So we need to put h equals 7, and total length of IP address is 32. If out of 32 bits address, 7 bits are host bit, then how many network bits are there? 25. Then how many network bits are there? 25. Clear? Now we need 25 network bits. So my network will be this one, 192.168.10.0/25. So here you can see there are two network, because we have borrow one bit, right? 2 to the power and 2 to the power 1 means 2. My first network is, let me decrease the size of my pen. My first network is 192.168.10.0, and my second network is 192.168.10.128. This is subnetting, right? Block size. How you will find block size? Formula to calculate block size is very simple. 256 minus subnet mask of that octet where last one is present. So last one is present in 4th octet, and 4th octet is like this, 1 and 7 times 0, 4, 5, 6, 7, right? So subnet mask will be 128. Minus 128, you will get 128. This is your block size, right? So this is my second network /25/25. This is my first network. Here you can configure 126 computer, right? How many valid host will be there? 126. Now for department 2, we will do VLSM from this network. Now, right? This is fine for department 1. I will give this network ID with /25 in department 1. Now in department 2 we need how many valid host? 50, right? So formula is valid host must be greater than and equal to 2 to the power 50, right? And formula of valid host is 2 to the power h minus 2 must be greater than and equal to 50. So if you will put h equals 6 over here, right? So you will get 62 minus 64 minus 2, that means 62 is greater than and equal to 50. Your requirement is fulfilled, right? So host bit should be 6, right, for 50 user. So if there are 6 host bit in 32 bits of IP address, how many network bits are there? 26. So here we need to put /26, and if you will use CIDR value /26 over here, what will be your first network ID? This is my network for department 1, right? And this is my network for department 2. Here slash value is 16. So what will be the subnet mask for /26? 255.255.255. In last octet 2 bits are 1, right? Means 128 plus 64, that means 192, right? Then block size will be what? Block size will be 256 minus 192. So here you will get 4 and here you will get 6. So block size is 64. That means my next network will be what? 192.168.10.128 and plus block size, that is 64. So 291.192, right, /26. And last IP address of this network will be 192.168.10.191. Last IP address of this network will be for department 1, 192.168.10.127, right? So there you can see in department 1 there can be 126 user. In department 2 how many user can be there? Formula is 2 to the power h minus 2 to calculate valid host. How many host bits are there? You can see /26 means we have 26 network bits. That means we have 6 host bit. So h equals 6. So 2 to the power 6 minus 2 means 62. So you can configure 62 computer in this network, and we need 50 IP address for department 2. So yes, my requirement is fulfilled. So this network will be for department 2, right? This is for department 1 and this one is for department 2, right? Now I have this network. This is free now. Now for department 3 we need how many hosts? 26. Again formula is 2 to the power h minus 2 is must be equal to and greater than 26. Now if you will put h equals 4, 5, we need to put 5. So if you will put 5, then you will get how many IP address? 32 minus 2 means 30 is greater than and equal to /26, right? So host bit should be 5. That means network bit will be what? 32 minus 5 means 12 7, right? 32 minus 5 in 7, or here you will get 2. That means 27 network bits should be there. So here I will change this /26 to /27, right? Let me erase it, these things. Okay, so here how many IP address I will get? Okay, so if CIDR value is /27, then what will be the subnet mask? 255.255.255.192 plus 32. 192 plus 32 means 4, and 224. You will get 224. This one will become your subnet mask. Block size will be what? Block size will be 256 minus 224. Here you will get 32. Sorry, 32. So your next network will be what? 192.168.10.192 plus 32. So 224 over here, and 10 to 2 to 4. So this one will be your next network /27. Here how many valid hosts can be there in this network? So formula is 2 to the power h minus 2 to calculate valid host, and h equals what? H equals out of 32 bits IP address, 27 are network bits. That means 5 are host bit. So 2 to the power 5 minus 2, you will get 32 minus 2 means 30. And for department 3 we need 26 IP address. So this network is fine for department 3. For department 3 this network is fine, and this network is for department 4. But in department 4 you can see we have 30 IP address, but we need only 5 IP address. So again we can do VLSM. Again formula will be same, 2 to the power h minus 2 must be equal to greater than and equal to 5. Here we need to put h equals what? 3, right? Means if my host bit are 3, that means how many network bits are there? 29. So here you can use /29 to reduce the wastage of IP address in department 4, right? So /29 192.168.10.224 /29 is fine for department 4. So guys, now you can see, let me remove this thing, how I will configure IP address in department 1, department 2, department 3, department 4, department 5. You can see for department 1 my network ID is 192.168.10.0/25, right? This is for department 1. For department 2 my network is 192.168.10.128/26. This one is for department 2, right? 192.168.10.192/27. this one is for department 3. 192.168.10.224 224/29 is for department 4. Department 4. So this is for department 1, department 2, department 3 and department 4. Here you can see in department 1 we have 126 valid host, in department 2 we have 62 valid host, in department 3 we have 30 valid host, and in department 4 how many valid hosts are there? Guys, network bits are 29. That means how many host bits are there? 3. So 2 to the power 3 minus 2. 2 to the power 3 minus 2 is 8, minus 2 means 6. We have 6 valid hosts in department 3. Okay, so hope you like this video. If you like this video, please hit on like button, guys. That's all for today. We will meet soon in next video. Till then, stay safe. Bye bye.